Hello friends and my dear students, this is my new playlist where I will be discussing about mathematics of class 11, primarily focusing on solving problems for that will help you for the competitive examinations like JEE Mains, JEE Advanced and WBJEE. So this is I'm starting with the chapter of limits, not chapter, rather the concept of limits. All the videos I will not be following. I will not be discussing the I will not be following the syllabus chapter wise, but I will rather my content will come at very random in random order. Like the next video could be from any chapter of any topic. So this part one video. So this video is part of the concept of limits, and this is the part one video where I will be discussing the very basics of limits that one should understand very well before solving the problems of limits. If you find this video beneficial, then please like it, share it with your friends, and please inspire me and support me so that I get the push to come up with better content, trying to understand and discuss the concepts of all the concepts that is in the syllabus of mathematics 11 as well as class 12. So this video will be part of the playlist problematic mathematics for class 11. Now the word problematic is has two meaning. First, problematic, I mean to say the videos will be more of problem solving, so problematic. And another meaning is that mathematics of 11 and 12 is really problematic, means it gives a lot of problem. You have to really do a lot of critical thinkings to solve the problems of competitive examinations like JEE Mains, Advanced or WBJEE. Even nowadays the boards are also giving problems which are very much at the level of these competitive examinations. Anyway, so let's start the part one video on the very basics of limits. Okay, so I have prepared quick notes for discussing. So primarily I will discuss what exactly is meant by x tending to a, x tending to a plus or x tending to a minus, and what do we mean by limit x tends to a, limit of a function when x tends to a. Now I will be using a few notations, so it might sound very boring, but if you understand the notations, it is the concept behind this notation is very simple. There is nothing really, it is not at all complicated. Okay, now to understand what exactly is meant by x this arrow operator means tends to, so this means x tends to a, this means x tends to a positive, and this means x tends to a negative, or tending to a negative, x tending to a positive, or x tending to a. What exactly does it mean? Now before that, a few things we must understand. The first thing is what is meant by the neighborhood of a point x equals to a. So along the x line we know, so this is all about functions, that is fx. X is along the values of x is along the x axis and fx is along the y axis. So what is meant by the neighborhood of a point x of a point or of a value of x equals to a. Neighborhood is basically an interval or a set which is denoted by I hope I am not maybe this is not the exact notation, or it could be, I don't know. So capital N A subscript a means it denotes the neighborhood of the point x equals to a. So it is a interval or a set of points or real values, that is, it is an open interval from a minus delta to a plus delta. A is the value around which we are finding the neighborhood. Now what is delta? Delta is an arbitrarily small positive value, as much small value that you can consider. I can say delta to be, let's say, 10 to the power minus 9. You can say delta to be 10 to the power minus 12. Both are fine. I mean, there is no specific value of delta, but it is a in general it is a very small, extremely small value. Okay. So the neighborhood of the point x equals to a is the set of all points that is greater than, you can see, that is in the interval a minus delta to a plus delta, which means all those values of x are greater than a minus delta and less than a plus delta. Okay. Now, what is deleted neighborhood of point x equals to a? I am denoting it with the DNA. Now, I don't know whether actually in mathematics a deleted neighborhood of point x equals to a is denoted by DNA or not. This is my convention, but please, this is just for the sake of discussion. So DNA is the deleted neighborhood of point x equals to a. It is also the set or interval of points or values. It is the same as NA, but you exclude the point value x equals to a. So it is as you can see, this is NA, the neighborhood of the point a minus the point a. So the deleted neighborhood of a point x equals to a is all the points, all the values of x, which is you can say greater than a minus delta, less than a, and or it is greater than a and less than a plus delta. So this is the set or interval for deleted neighborhood of a. Okay. So this deleted neighborhood of a is primarily will be used is basically we need to understand for understanding the x tending to a. Okay. Another two thing is that what is left deleted neighborhood of point x equals to a. Left deleted neighborhood of the point x equals to a, which I am denoting with DNA a minus is standing for left, which means all the values of x which are greater than a minus delta and less than a. So as you can see in the graph, I have in this figure, so this is x axis and this is y axis, and this is x is equal to a, the line straight line x equals to a. The point a is the point a 0, and b is the point a plus delta 0, and c is the point a minus delta 0. So as you can see, the neighborhood of point x equals to a is the set of all the values of x, this interval, this interval. Okay, this interval. Okay, now what is left deleted neighborhood of a? It is very clear that all the values of x which are greater than a minus delta and less than a. And what is right deleted neighborhood of the point x equals to a? It is all the values of x which are greater than a but less than a plus delta. Now since delta is a extremely small value, you can consider the right deleted neighborhood of the point x equals to a to be a very small interval where all the values in that values are greater than a. And the left deleted neighborhood of the point x equals to a, you can consider that to be an extremely small interval where the values are less than a. Okay. Now what is I have discussed these neighborhood, deleted neighborhood, left deleted neighborhood, right deleted neighborhood, just to assist me in explaining the concept of x tending to a and x tending to a minus or x tending to a plus. Now what does this mean? This is a mathematical notation of saying x is the value of x is approaching towards a. A is a constant, a is a fixed real number. The value of x is approaching towards a, or we say x tending to a or x tends to a. Now this notation is not mentioning a very specific value of x. No, x tending to a does not mean of a specific value of x. No, all the values of x, which are, as you can see, which are in the interval which are in the set of left deleted neighborhood of a, that is dna minus, or in the right deleted neighborhood of a, that is dna plus, then any value of x which is lying in this set, for any value of x which is lying in this set, that is dna minus union dna plus, I can say that that value of x is tending to a. So basically, I mean, to be in plain English, the value x tending to a means a value of x which is very close to a, and it could be greater than a or it could be less than a, but definitely it is not equals to a. This is very, very important. X tending to a means it is not equals to a, but it is little more than a or little less than a. Okay. Now what is x tending to a minus? A minus means that x tending to a minus means x is approaching the value a from the left hand side, which means that if you consider any value of x which is in the set or interval dna minus, that is the left deleted neighborhood of a, then for all those values of x I can say that x is tending to a minus. So here also x tending to a minus does not mean a specific value of x. No, it means a lot of, I mean, you can say an infinite values of x. There are infinite values of x that will satisfy that x is tending to a minus, and those, what is that infinite set of values? Those values are nothing but the set dna minus, that is the left deleted neighborhood of a. Basically, any value of x which is greater than a minus delta and less than a, for any such value of x I can say that x is tending to a minus. The same concept applies for x tending to a plus. A plus means x tending to a plus. X tending to a plus means the value of x is approaching towards a from the right hand side. That is, you consider any that is the value, any value of x which is extremely close to a but greater than a. For any such value of x I can say x is tending to a plus. Basically, any value in the set of right deleted neighborhood of a, I can say x is tending to a positive. That is, for any value of x which is greater than a but less than a plus delta, I can say x is tending to a plus. I hope I was able to make clear what exactly we mean by x tending to a, x tending to a minus, and x tending to a plus. The main thing is to note that in all these three cases x is not equal to a. They are either a little, x tending to a means x is either just a little more than a or just a little less than a. X tending to a minus means x is, the value of x is just a little less than a, and x tending to a positive means x is just a little more than a. Okay, so that was all about x tending to a, or x tending to a positive, or x tending to a negative. Now, what do we mean by this? That now this is a mathematical notation. This is a mathematical notation. If I want to express this mathematical notation in plain English, in English I will say the limiting value of fx when x tending to a is L. Now this is you have to be very very clear about what the languages I am using. This means the limiting value of x when x tending to a is L. I am not saying the value of the value of fx is equal to L when x tending to a. No. Okay. So this whatever you see inside the box, that is a mathematical symbolic expression this can be expressed in mathematical terms in another way, that when x by this, when x tends to a, the function fx tends to L. What does this mean? Fx tends to L. This means that the value of fx, whatever the value of fx is approaching towards L, the exact value of x, the exact value of fx is not equals to L. In general, fx is not equal to L. The value of x is approaching towards L either from the right hand side or from the left hand side. That is, when the value of x is tending towards a, that is, when the value of x is very close to a, then the value of fx at that value of x is very close to L, but it is not, in general, not equals to L. Okay, so now what is the mathematical explanation when I say that when the value of x is approaching towards a, then the value of fx is approaching towards L? What does it mean? The mathematical way of explanation is, if you consider two values x1 and x2 which is in the deleted neighborhood of a. Now when I say x tending to a, that means any value of x which is in the deleted neighborhood of a will mean it is tending to a. That is, the actual value of x you are considering could be a little more than a, or it could be a little less than a. Consider any two such values x1 and x2 which is either little more than a or little less than a. Now we say that now if x1 is closer to a, if the value of x1 is closer to a than x2, which actually means the absolute difference of x1 and a is less than the absolute difference of x2 and a, then we say then the value of fx1 will be closer to L than the value of fx2. So this is the mathematical explanation of this short form of this limit x tends to a fx is equal to L. If I want to describe this in a more detailed form, mathematical form, then that is this one. When x tending to a implies fx tends to L. That is, when the value of x is approaching towards a, then the value of fx will approach towards L. A further detailed explanation of this statement is that if you consider any two values x1 and x2 which is where x1 and x2 obviously is very close to a, it is in the set of deleted neighborhood of a, then if x1 is closer to a than x2, which actually means this, that is the absolute difference of x1 from a is less than the absolute difference of x2 from a. If this is the case, this will imply that the absolute difference of the value of fx1 from L will be less than the absolute difference of the value fx2 from L. I mean, if you are familiar with the concept of set and all this mod operator, I hope this will make clear sense to you. Okay. Now this thing, limit x tending to a fx is equal to L, it is just a mathematical notation, or it is just a short form of saying that when x is tending to a, then the value of fx is tending to L. In this case, the key concept is that x is never taking the value of a, and x is definitely not taking the value of a, and in most of the cases the value of fx is also not taking the exact value of L. The value of fx is very close to L when the value of x is very close to a. Okay, so that was limit x tends to fx x tending to a, limit of fx x tending to a equals to small l. Now similarly we have limit of fx when x tending to a minus is equal to l, means that when x is tending to a minus, then the value of fx is tending to l. That is, if you consider, I mean, it is exactly the same, the meaning is exactly the same as limit of fx x tending to a. It is only that in this case we are only considering any value of x which is just a little less than a, that is in the left deleted neighborhood of a. So it means that if you consider two values x1 and x2 which is in the left deleted, this means left deleted neighborhood of a, which basically left deleted neighborhood of a, which basically means that both x1 and x2 is greater than a minus delta and less than a. And if x1 is closer to a, then x2, then fx, the value of fx1 will be closer to l than a value of fx2. So the mathematical interpretation is same, that if absolute value, if the absolute difference of x1 from a is less than the absolute difference of x2 from a, this means nothing but x1 is closer to a than x2. So if x1 is closer to a than x2, then the value of fx1 will be closer to l than the value of x2. This thing means the value of x1 will be closer to l than the value of x2. Okay, that was a minus, where the x tending to a minus, where we were considering any value of x in the left deleted neighborhood of a, or you can say any value of x which is just little less than a. The same thing applies for limit x tending to a positive. Now again this thing, that limit of fx when x tending to a minus is equal to l, it is just a short form or mathematical symbolic form to mean that when x is tending to a minus, it implies that the value of fx is tending to l. Okay, the same thing applies for limit of fx when x tending to a positive is equal to l. This again means that when x is tending to a positive, then the value of fx is tending to the value l. Now this small l is a fixed real number. Remember this, that note that this is limit all these l values on the right hand side are fixed real number. Okay. Okay. So limit of fx x tending to a positive is equal to small l. So what does it mean? In this case, if we are considering any value of x which is just little more than a, which means all those values, any value of x which is in the set of deleted right neighborhood of deleted neighborhood of a, that is DNA plus, which means nothing but any value of x which is greater than a and less than a plus delta. So now so any value of x which is little, if you consider any two values x1 and x2 which is just little more than a, or if x1 and x2 are two values in the set DNA a plus, that is in the right deleted neighborhood of a, and if x1 is closer to a than x2, whose mathematical interpretation is this means x1 is closer to a than x2, then that will mean that the value of x1, the value of fx1 will be closer to l than the value of x2, which is mathematically stated. This is the mathematical interpretation of saying that the value of fx1 is closer to small l than the value of fx2. Again, this thing, a limit of fx x tending to a plus a positive is equal to L is just a symbolic, is just a short form, a symbolic notation to mean that when x is tending to a, the value of x is approaching, when x is tending to a positive, which means the value of x is approaching towards to a from the right hand side, or any value of x which is just little more than a, then the value of x the value of fx will tend to L, which means that the value of fx will be very close to L. Now, one thing to note, that when I say fx tending to L, this does not necessarily, now this could mean that the value of fx is little more than L, or it could be less than L. In general, it is not equal to L, but there are some cases of fx for some specific fx function. We will see that the value of fx is exactly equal to L, whatever the value of L is. But in general, in most cases, by this we mean that the value of fx is not equal to L, but it is either little more than L, just little more than L, or it is just less than L. Okay, now few key. Now I think I have, with the best of my ability, I have explained what it means by x tending to a, x tending to a positive, x tending to a negative, and the limit of fx when x tending to a is equal to L. Now a few key things to note is that when we say that limit fx x tending to a is equal to L, this in most cases does not mean that if a is equal to L. No, this thing is not saying that fa is equal to L. No, first of all, we are considering x tending to a, we are considering a value of x which is not equal to a, So in finding the limiting value of fx when x is tending to a, we are not at all concerned about the value of the function f at exactly the point a. The function fx may not exist, may not be defined at x equals to a, but still the limiting value, that is the small l, may exist. So in finding the limit of a function at when x is tending to a, the value of fx, whether the function is defined at the value of x or not, is not at all related. We are not at all concerned or bothered what is the value of the function fx at x equals to a in finding the limit fx when x tending to a. So limit of fx when x tending to a is equal to L, it definitely does not mean that fa is equal to L. No, first of all, it means that when you are considering a value of x which is either a little more than a, or it is little less than a, then the value of fa, then the value of not fa, sorry, the value of that value of x, which you are considering, which is little more than a or little less than a, at that value, at that point, the value of x will be very close to L. It will not, in most cases, it will not be equal to L, but it will be very close to L. That is, it could be little more than L, or it could be little less than L. Again, also, x tending to a definitely implies that x is not equal to a. X tending to a, we are not definitely means all those values of x which are not equals to a, but little more than a or little less than a. So similarly, x tending to a positive definitely implies that the value of x we are considering is more than a, that is x greater than a, and x tending to a minus implies definitely that x is less than a. Whatever value of x we are considering, it is definitely less than a. So okay, so one thing, note that when x is tending to 0 positive, which means that you take any value of x which is little more than 0, then the greatest integer function box x will be equal to 0. It will not be actually, it will be improper to say that the box of x tending to 0 when x is tending to 0 positive, because if you take any value of x which is little more than 0 and the box of x is obviously exactly equal to 0. So x tending to x, when x tends to 0 positive, then box of x is equal to 0. That is the correct way of saying, rather than box x is tending to 0. No, the box of x is equal to 0. So this is one example of fx where we can say that when x is tending to a, then fx is equal to L, but not fx tending to L. Similarly, if x is tending to 0 negative, that is, if you consider any value of x which is little less than 0, then obviously box of x will be equal to -1. It will be improper to say that when x tending to 0 minus, then box of x tending to -1. No, it will be exactly -1. So that was all that I wanted to discuss about the meaning of x tending to a or x tending to a minus, x tending to a positive, where a is definitely a fixed finite value, and the meaning of a limit of fx x tending to a is equal to small l, or limit of fx when x tending to a positive or a negative is equal to small l. So this this thing, even though while solving the problems, all these concepts will not be really, will not be really that much used, but ethically it will be a crime if you do not understand these very basic things. This should be very, very clear. So if this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and in that case do not forget to press the bell icon so that you will be notified by my future videos. In the next video I will discuss about some very preliminary limiting values when x specifically when x tends to infinity, negative infinity, and 0 positive and 0 minus, then some very and what will be the tending value of some very preliminary functions or some expressions of x, which you must also understand or clearly, or you must be very clear of those concepts, which I will discuss in the next video. So I am ending the video here. Thanks for watching, and until the next video, take care and bye.